Good morning, everyone. In today's session, let us discuss about the candidate elimination learning algorithm. This candidate elimination algorithm computes the version space, which is containing all hypotheses from H that are consistent with an observed sequence of training examples. We already know what is meant by a consistent hypothesis. If our example is positive, our hypothesis should also classify it as positive. If our example is negative, then our hypothesis should also classify it as a negative. Then only we say the hypothesis is consistent. Otherwise, we'll say it is inconsistent. Let us work with Enjoy Sport dataset in this example, which has three positive attribute values and one negative attribute value for the target attribute Enjoy Sport. The finders algorithm is finding only the maximally specific hypothesis. That means only the specific boundary is set. Whereas in the candidate elimination algorithm, the negative boundary will also be set here. We will be working with both positive as well as negative examples here. So first, let us set the general boundary. Initialize capital G, the general boundary, to the set of maximally general hypothesis in H. What is maximally general value? That is a question mark. So here we have 6 attributes: sky, air temperature, humidity, wind, water, and forecast. We will not consider the target attribute, that is enjoy score. So we will replace the general boundary with all 6 question marks. Then coming to the specific boundary. Initialize the specific boundary capital S to the set of maximally specific hypothesis in capital H. So we will replace all 6 attribute values with 6 phi's. This is our specific boundary. Then we will examine each and every example, and if it is a positive example, then we do the following steps. Let us do this with an example. So let us take the first example and let us also take the specific and general boundaries. Let us start with this. This is our specific boundary. It's not. This is our general boundary. So what it says, if D is a positive example, yes, the first example is positive. Remove from G any hypothesis inconsistent with D. Okay. So here in the general boundary, we have all question marks. That means any value of the example is accepted. That means the first example is classified positive by our general hypothesis. Actually, it is a positive example. Hence, it is consistent. So no more changes to the general hypothesis. Let us mark it as G1. Coming to the specific boundary. For each hypothesis S in S that is not consistent with the D. So this is our specific hypothesis. And let us see what this classify our first example. Okay. So here we have all 5's. That means none of these values, attribute values, are acceptable by this hypothesis. So this will classify my example 1 as a negative example, but it is a positive one. Inconsistent classification. So what should be done? Add to S, remove S from S. Okay, so we will not consider this anymore. And add to S all minimal generalizations of H such that H is consistent with D and some number of G is more general than H. So what I should do in the next specific hypothesis, I should replace the 5 values with the more specific, more general value. That is, replace 5 with sunny, next 5 with warm, the third 5 with the value normal, fourth 5 with value strong, fifth with warm, and sixth with same. This is my specific hypothesis 1. Now this will classify My example is positive and this is a positive example. So H has become consistent with the current example. Okay. And some member of G is more general than H. Yes. So this general hypothesis is more general when compared to this hypothesis. Coming to the next step, remove from S any hypothesis that is more general than another hypothesis in H. Here we have only one hypothesis. There is no other hypothesis which is more general than this. So no more changes to S1. Now let's move on to the next example. This next example is also a positive example. B is a positive example. And coming to G. So let us see what our general hypothesis classifies with this example. So we have all question marks. So again, the second example is also classified as positive by my general hypothesis. Actually, it is a positive one. Okay, so no changes to the general hypothesis. So it remains the same. Then coming to the specific hypothesis. Okay, so specific hypothesis right now is S1. Okay, so let us check whether this will classify my second instance also as positive or not. Okay, so here I have sunny. Here also I have sunny. Here I have warm. Here I have warm. But here I have normal. But here I have a value high. So here is my first mismatch. Because of this, I hypothesis S1 will classify the second example as negative, but actually it is a positive one. There is an inconsistency. Why this inconsistency has occurred? Because of the change here in the third attribute. Rest all are matching with S1. Only this attribute is not matching. Because of this, there was a inconsistency. So we should make this as more general. So let us replace. The first two values remains the same. Let us replace this normal with the next more general value, which is a question mark. Remaining values are the same: strong, warm, and same. So now this hypothesis should classify both my examples as positive only. So let us check with the first example: sunny, warm, question mark. Sunny, warm, and normal. Any value is accepted by question mark. So consistent. Next is strong, warm, and same. So it is correctly classifying the first example. Coming to the second example, sunny, warm, high. In place of high, we have a question mark. So high value is accepted. Strong, warm, and same. Okay. It is correctly classifying the second example also. And some member of G is more general than this. Here also we have a question mark. Here also we have a question mark. So no more changes to the general boundary also. And now this S2 is consistent with the current example. Next, moving to the third example. This is a negative example. So let us move on to the third step, and there we will work with the negative example. So here all the steps, if you observe, it is similar to the previous one. The only change is there if we take specific boundary, here we will take general boundary and we will make the changes. So the third example is a negative example. So remove from S any hypothesis inconsistent with D. What is our specific hypothesis? The specific hypothesis that we obtained is sunny, warm, question mark, strong, warm, and same, right? So this we already worked out in the last step. Strong, warm, and same. So this is our specific hypothesis. So now let us check whether this specific hypothesis will correctly classify my example or not. So the first value here is sunny, but here it is rainy. Okay. So because of this, this example will be classified negative by my specific hypothesis. Actually, this is a negative example. So it is a correct classification. S2 is consistent with the example. Coming to the general boundary. So when we come to the general boundary, here we have all question marks. So that means this question mark will accept the value rainy also. So what was the classification given by this general boundary? It is classifying the third example also as positive, but it is a negative example. There is an inconsistency. So we should handle this. How we can handle? Remove G from G, add to G all minimal specialization. So now this general value I should replace with the special value, specialization value. So like that, we should write for all the six attributes, because if one value is accepted also, this will classify my hypothesis as positive. So I should not let it happen. So let us write the question mark with a specific value. So the first specific value that I should write. So the first question mark should be replaced with a specific value. Which value should I take? Should I take rainy? If I take rainy followed by all question marks, again this hypothesis will become a positive classifying one. But I need a negative, so I should take an opposite value of rainy. Opposite value of rainy is sunny. Sunny, question mark, question mark, question mark, question mark. Next, coming to cold. Opposite value of cold is warm. Question mark, question mark, question mark, question mark. Then here I have a value high. Here I have question mark. So an opposite value of this I should consider. Question mark, question mark, question mark, question mark, question mark. Then the next value is strong. There is no opposite value to this. So I'm leaving this one. Next, coming to the next attribute, here we have warm. So let us take an opposite value of this, that is cool. The next attribute, opposite value of that I should take. Here actually I have a value change. Opposite of that in this particular column that I have is same. Okay, so these are the hypotheses that are resultant. So if you want, actually you can write for strong also. Actually there is no opposite value, so we can only write strong itself, but I will show you it gets eliminated. How it will be, let us see. So now coming to the first one, what should happen? This hypothesis H should be consistent with the current example, and some member of S should be more specific than this H. Let us check. So sunny followed by all question marks. Okay. So this classifies my example as negative because I have rainy here. So it classifies as negative. Our example is also negative. So this is a consistent hypothesis. Coming to the next one. This is also consistent because here I have a value warm. Here I have cold. Okay. So this will classify my hypothesis as an example as a negative. Example is actually negative. So fine. Coming to the next one. Here I have a value high. Here I have normal. So this will classify my example again as negative one. So it is consistent. So let us keep this two. Coming to the next one. Here I have a value cool. Here I have a value warm. So consistent. Let us keep this two. Coming to the next one. All followed by same. So this is classifying my example as a negative. My example actually is a negative one. Fine, let us keep it. Coming to this particular one. So here the fourth attribute value is strong. Here. So the fourth attribute value is strong. So because of this, this hypothesis will classify my example as a positive, but my example is a negative one. So I cannot keep this because this is an inconsistent hypothesis. Okay. So now what we should do? Again, coming to the specific hypothesis. Remove from S any hypothesis inconsistent with the example. Okay, so now let us see how many of these hypotheses are correctly classifying the other examples as well. Let us see that. So let us do that with a specific example because the specific example already classified these two correctly. So we'll do with the specific. Okay, sunny followed by all question marks. Fine, this is acceptable. Warm followed by all question marks. Yes, it is classifying the other two as positive. I can keep. Then coming to the next. Here I have a question mark, but here I have a specific value. Because of this, my example will be inconsistent with this hypothesis. So I will remove this. Next, here I have strong. Okay, so anyhow, this is eliminated. Moving to the next. Here I have warm, but what I have here I have cool. So that means it is inconsistent. So I should remove these two. Here I have same, here also I have same. So finally we are left with three hypotheses in the general boundary. That is sunny, question mark, question mark, question mark, question mark, question mark, and then question mark, question mark, question mark, question mark, and then question mark, question mark, question mark, five question marks followed by same. So these three are the remaining consistent hypothesis that I have in the general boundary G3. So now moving to the next example. The next example is a positive example. So I should work with the specific boundary. So in the specific boundary, what I should do? So the first value sunny sunny matching, warm and warm matching, question mark and high matching, strong and strong matching. Here there is a change. Warm and cool. Because of this, my example 4 will be classified as a negative example, but actually it is a positive. So I should make changes to my specific hypothesis. So wherever there is a mismatch, let us just replace that with a question mark. Sunny, warm, question mark, strong. There is a mismatch with warm, so let us replace that with a question mark. There is a mismatch with the same, let us replace that with a question mark. So now let us check whether this is consistent with my general boundary too. Okay, so if I check with the general boundary, I should remove from the general boundary any hypothesis which is inconsistent with this specific hypothesis. What is inconsistent? In that way, if I see, so this one is inconsistent. So here I have more general value question mark, but here I have same. So I should remove this. I should remove this. So in G4, I will be left with only two hypotheses, that is sunny followed by all question marks. Then question mark, then all question mark. So these are the only two hypotheses that we are left with. Okay, so now we are done with all the changes in the specific as well as general boundary. So now these values are acceptable by all the examples. So now let us see how the version space is built. Okay. So this is the final value of specific boundary and general boundary that we obtain. So now we should make little more modifications to the version space. So in the version space, we will compare the specific boundary with the general boundary. So first let us take the first hypothesis in the general boundary. This is this. So now let's compare sunny and sunny matching. Here I have a question mark, here I have warm. So wherever I have a question mark, that should be replaced with a specific value in the version space. Followed by this restaurant question marks. At a time, we will make only one question mark with a specific value. Next, once again, let us compare sunny, sunny. So for this form, already we added. So let us start with the third question mark and question mark. Here I have strong. Here I have a question mark. So again, let us replace this question mark with the specific value strong. Sunny, question mark, is strong. Fourth question mark is replaced with value strong. Question mark and question mark. So next two are matching. So no more changes. Next, coming to the second hypothesis in the general boundary. So here we have a question mark. Here I have sunny. So there is a mismatch. So let us replace this with sunny. If I replace, what will happen? This will become sunny warm followed by all question marks. Already I have added that in the version space. So I will not reconsider it. We need not write it again. Next, coming to the next one. Third question mark. So here the third one is a question mark. Here also a question mark. Next, fourth one is strong. Here fourth one is a question mark. Here we have a value strong. So we will replace this. Question mark. One, question mark, one. Followed by this we have two question marks. Question mark and question mark are matching, so no more changes. So three more hypotheses are added in the version space. So let us map it. From this we obtain these two. And then from this hypothesis we obtain this and this. So finally all these are mapping to this. So this is how the version space is built up. Hope you followed the video. If you have any queries, please do post in the comment box so that I can answer your questions.